All right, once again, we are working with this problem right here, the information given to us here, where the height of a rider on a Ferris wheel can be modeled by the sinusoidal regression function. H is equal to 6 sine of 1.05t minus 1.57 plus 8. And H is the height and T is the time. Now, the question that we're working on, sorry, let me just clean this up a little bit. The question we're working on is this one. It says, when the rider is at least 11.5 meters above ground, she can see the rodeo grounds. Sorry, it's weird. I'm reading back and forth between paper and the camera here. During each rotation of the Ferris wheel, the length of time that the rider can see the rodeo grounds to the nearest tenth of a minute is what? Okay, now, again, the way that's given to me here, this implies that I'm supposed to be using the calculator. So, once again, when I use the calculator, I'm going to do approach this graphically. I'm going to make sure that I'm in radian mode. It should always be in radian mode. I've already entered the equation in. This was from the last question that we did here. And my old window settings should be fine for this particular problem. I'm not seeing a full rotation, but I don't think I need to, but we'll find out in a second here. We're interested in the amount of time that that person is above 11.5 meters. Okay, well that's a height. That's a y coordinate based on the way I've set this up here. So I'm going to put 11.5 here. Now we're going to graph this. Now in the previous question, I was interested in that first point of intersection because the question was, at what time does this person first get past 10 meters? That was the previous question. Now the question is, how long are they above 11.5 meters? So this is what we're going to do. Okay, I'm going to find that first point of intersection. So second, trace to get us into the calculation menu, intersect. So we're going to move our cursor close to that point of intersection, press enter for the first curve, enter for the second curve, and then enter to get past the guess. And I get this number 2.088 blah blah blah. Now, I could write that out, but you know what, I'm kind of lazy here. So I'm going to quit. Now it turns out when you do this, the calculator stores that number because it was an x coordinate, it stores it in x. And so that's the number that we just found, 2.088 and so on. Now I'm going to do the same thing and I'm going to pull this with that other point of intersection and I'm going to pull the x value out of that again. Now by the time I get to that second part of this problem, the calculator will have already changed x. So what I'm going to do is I'm going to store that number someplace else. So I'm going to press the store button here. And now I'm going to pick a variable, and I'm pretty lazy. I'm going to pick A. So alpha, and then math button gets me the A. So I'm going to store that answer in A. There we go. So now, when I press the A variable, that's the number I'm going to get. Now I go back to the graph here. Now I want to know what that time is. So second, trace, intersect. Oh, we slide the cursor over. Now we need the cursor to be close to this other point of intersection. Am I in the first curve? Yep. Did I jump to the second curve? Yep. Is it okay to guess this number? Yep. And it thinks for a little bit, finds that point of intersection. Now it stores that in X. I'm going to quit. When I press X, it's now this new value. But I'm interested in the difference between them. How long this person is above, okay, is above this time here. So that person isn't above that for 3.89 minutes. That person gets up to that point at 2.088 minutes and then drops back down again. So I want the difference. So I'm just going to press subtract. Okay, so this will be this number, subtract, and now I'll do alpha math to pull that A up again. And there it is. My answer is that person, that girl is above that height there for 1.8 minutes. Okay, so to the nearest tenth of a minute, 1.8 minutes. And that's what they're looking for.